Good day, my name is Ben van Wyk and I am the Deputy Chairperson of the Engineering Council of South Africa's Engineering Standards Generating Body, or ESGB. Based on many requests from industry and academia, the ESGB at the beginning of 2013 decided to prepare a presentation on the work done during the past 5 or more years on the new HEQSF aligned engineering standards ECSA developed. Although the development of this presentation was truly a joint ESGB effort, I need to acknowledge that many of the slides were adapted from those originally prepared by Professor Hugh Hanrahan during the time he served on the ESGB and various other ECSA bodies. Please pause the presentation if you need more time to assimilate what is presented. The purpose of this presentation is to give an overview of the revised Higher Education Qualifications sub-framework, how it fits into the National Qualifications Framework, and the associated qualification standards developed for technicians, technologists, and engineers. The National Qualifications Framework has 10 levels, each with an associated level descriptor and 3 sub-frameworks. Number 1. The General and Further Education and Training Qualifications Sub-Framework, or GFETQSF, contemplated in the General and Further Education and Training Assurance Act, which is developed and managed by Umalusi. Number 2. The Higher Education Qualifications Sub-Framework, or HEQSF, contemplated in the Higher Education Act, which is developed and managed by the Council on Higher Education, or the CHE. Number 3. The Trades and Occupations Qualifications Sub-Framework, commonly known as the Occupational Qualifications Sub-Framework, or OQSF, contemplated in the Skills Development Act, which is developed and managed by the Quality Council for Trades and Occupations, or the QCTO. This is a graphical presentation of how this fits together. As you can see, the OQSF spans all 10 levels of the NQF. But when this presentation was prepared, there was no clarity on levels 7 to 10. The GFTEQSF spans levels 1 to 4, and when this presentation was prepared, there was uncertainty about level 5. The HEQSF spans levels 5 to 10. Starting with the higher certificate at level 5 and terminating with the doctoral degree at level 10. South African universities and universities of technology are allowed to offer qualifications specified in the HEQSF. The revised HEQSF, in line with the previous framework, provides the basis for integrating all higher education qualifications into the National Qualifications Framework. It provides a basis for standards development and quality assurance. It provides a mechanism for improving the coherence of the higher education system and indicates the articulation routes between qualifications, thereby enhancing the flexibility of the system and enabling students to move more efficiently over time from one program to another as they pursue their academic or professional careers. The HEQSF establishes common parameters and criteria for qualifications design and facilitates the comparability of qualifications across the system. Within such common parameters, program diversity and innovation are encouraged. Higher education institutions have a broad scope within which to design educational offerings to realize their different visions, missions, and plans, and to meet the varying needs of stakeholders and communities they serve. Who is responsible for what? The Minister of Higher Education and Training has overall responsibility for the NQF and for determining the qualification structure for the higher education system. The South African Qualifications Authority, or SAQA, is responsible for the development of policy and criteria for registering standards and qualifications on the NQF on recommendation from the quality councils. The CHE is responsible for the development and management of the HEQSF and for advising the Minister on matters relating to the HEQSF, for the development of standards and quality assurance through its permanent subcommittee, the HEQC. Since HEQSA is a statutory body established in terms of the Engineering Professions Act to regulate engineering professions, the CHE agreed by means of an MOU to work with HEQSA to accomplish quality assurance and standards generation for engineering qualifications. The Engineering Standards Generating Body, or ESGB, is a high-impact committee of HEQSA. The ESGB develops and recommends to the HEQSA Council relevant competency and qualification standards for engineering practitioners at levels 5 to 10 on the NQF, in compliance with one or all of the relevant QCs. The ESGB has standard generating groups, or SGGs, to deal with matters pertaining to the generation of standards for a specific registration category or discipline. The rest of this presentation will focus on the revised HEQSF and the associated education standards developed for technicians, technologists, and engineers. Here you can see an overview of the qualification types, levels, and minimum credits as specified in the HEQSF. In other words, the HEQSF menu. For example, the higher certificate is at level 5, should have a minimum of 120 credits, of which at least 120 should be at level 5. Note that there are 3 types of qualifications: 2 diplomas and an advanced certificate at level 6. Also note that although the minimum credits for the 2 diplomas are different, that is, more than 240 and more than 360, all 3 qualifications at level 6 should have 120 credits at the exit level. Note that there are 2 types of qualifications at level 7 and 3 types of qualifications at level 8, namely the professional bachelor's, the honours, and the postgraduate diploma. This slide shows the HEQSA standards developed until February 2013. Developed standards have been gazetted for public comment and are compliant to the CHE framework for qualification standards in higher education. Note that the minimum credits specified are in most cases 20 credits more than the minimum specified by the HEQSF. The higher certificate at level 5 is aimed at engineering support occupations, of which there are many, and is not linked to a specific professional category. Someone who completed the higher certificate may continue with an advanced certificate in order to meet the educational requirements for registration as a candidate technician. There are 3 qualifications that meet the minimum educational requirements for registration as a candidate technician, namely the advanced certificate, Diploma in Engineering Technology, and the Diploma in Engineering. Both the Advanced Diploma and the Bachelor of Engineering Technology meet the educational requirements for registration as a candidate technologist, and the Bachelor of Engineering meets the educational requirements for a candidate engineer. Although the BEngTech Honours is not at the moment linked to a specific professional category, both the BEng and BEngTech Honours qualifications provide access to Master of Engineering or MSc. The BEngTech Honours has been designed in such a way that the University and University of Technology streams converge at the master's level. Universities of Technology also have the opportunity, if their staff profiles, infrastructure, and exit level outcomes meet the minimum requirements, to seek accreditation for a cluster of linked qualifications, such as the BEngTech, BEngTech Honours, and MEng, as meeting the educational requirements for registration as a candidate engineer. Although the DHET have differentiation guidelines for universities, technically speaking, traditional, comprehensive, and universities of technology may present any of the registered qualifications if they have the resources and can obtain all the necessary permissions from the DHET, CHE, and HEQSA. This is a graphical presentation of the previous slide. As mentioned, 3 qualifications, namely the Advanced Certificate, the Diploma in Engineering Technology, and the Diploma in Engineering at Level 6, meet the educational requirements for registration as a candidate technician. Both the Advanced Diploma and the Bachelor of Engineering Technology at Level 7 meet the educational requirements for registration as a candidate technologist, and the BEng meets the educational requirements for registration as a candidate engineer. Note that the Advanced Diploma provides access to the BEngTech Honours, and that both the BEng and BEngTech Honours qualifications provide access to the MEng or the MSc. The blue lines indicate possible transfer of accumulated credits. The blue lines only indicate that credits can be transferred, not how many or at which level the higher qualification may be entered. Please consult the HEQSF and the published standards for detailed rules and information. An interesting development in the HEQSF is that the higher certificate may also provide access to degrees, which might be useful for candidates not initially meeting the minimum entry requirements. Please note that a 240 diploma does not provide direct entry to an advanced diploma, and that additional credits from the 360 diploma should be completed. Also note that the standards have been designed in such a way that it is possible, if a university, possibly a comprehensive, offers both the BEngTech and BEng, that the 3+2 route can be created for a person to complete the BEngTech and BEng in 5 years. If syllabi can be aligned, such an arrangement will also be possible between a university and the University of Technology who want to collaborate. This slide shows nomenclature examples. Civil engineering has been chosen to illustrate the use of qualifiers. Please take a moment to read through the slide. The developed standards at levels 8, 7 and 6 have been developed to align with internationally defined profiles for technicians, technologists and engineers. Note how the profiles differ in terms of problem-solving skills, experimental design and testing, and engineering design. For example, engineers at level 8 are expected to solve complex problems. Technologists are expected to solve broadly defined problems, and technicians are expected to solve well-defined problems. Technicians at level 6 are expected to be able to search relevant codes and catalogs, to execute routine tests and measurements, and use design recipes to execute simple design functions. While engineers at level 8 need to design their own experiments and analyze and synthesize complex information to arrive at conclusions. They also need to be trained to use sophisticated strategies and tools to design and oversee complex systems, components, and processes. There is much confusion among industry and academia of what is expected of a technician, technologist, and engineer. It is therefore critically important that stakeholders study the standards to calibrate their understandings and familiarize themselves with internationally aligned expectations. Therefore, technicians at level 6 need a working understanding of engineering sciences underlying the techniques used, together with financial, legal, health, safety, and environmental methodologies. Technologists at level 7 need an understanding of engineering sciences underlying a deep knowledge of specific technologies, together with financial, commercial, legal, social, health, safety, and environmental matters. Professional engineers need a broad, fundamentals-based appreciation of engineering sciences, with depth in specific areas, together with financial, commercial, legal, social, health, safety, and environmental matters. Work-integrated learning issues. The HEQSF conflates work-integrated learning and cooperative education. There continues to be definitional, and conceptual confusion regarding will. Terms used both in South Africa and internationally, such as cooperative education, experiential learning, workplace learning, or workplace-based learning, tend to have a narrow focus on learning in a work context and are seen as separate from the academic curriculum. HEQSA defines work-integrated learning as an educational approach that aligns and integrates academic and workplace practices for mutual benefit of students and workplaces. Work-integrated learning is based on the principle that learning should be demonstrated to be appropriate for a qualification and should be assessed wherever it takes place or is provided. Work-directed theoretical learning, simulated learning using problem-based learning, and project-based learning are not work-integrated learning by definition, but may be used to incorporate work-integrated learning in a qualification. In conclusion, all HEQSA standards for technology qualifications make provision for incorporating work-integrated learning. Note, however, that the HEQSF distinguishes between the 280 and 360 diploma qualifications based on workplace-based learning. Both should include work-integrated learning, but according to the HEQSF, the 360 diploma may include up to 120 workplace-based learning credits. Refer to the HEQSA 360 and 280 diploma standards for more detailed information. The HEQSA 360 diploma standard specifies a minimum of 30 credits, normally one semester, of work-integrated learning. It is important to realize that if a qualification incorporates work-integrated learning, that the institution offering the qualification is responsible for placement and quality assurance. If a university, therefore, includes workplace-based work-integrated learning, the institution is obliged to find placement for the student and to quality ensure the learning taking place in the workplace. Effective workplace-based work-integrated learning will therefore only be possible if there is close cooperation between industry and universities. Universities also have the option to provide simulated workplace-based work-integrated learning if they have the facilities and other resources to do so. All engineering qualification standards at all levels have a common stem of exit level outcomes. For example, exit level outcome 1 deals with solving engineering problems, and exit level outcome 10 deals with acting professionally and ethically. The 360 diploma also have an 11th exit learning outcome related to work-integrated learning. Please take a moment to familiarize yourself with the common stem of exit level outcomes. The internationally aligned profiles, together with the exit level outcomes, were used to form the outcome statements you will find in the standards. For example, exit level outcome 4 deals with investigation and experimentation. The associated outcome statement for qualifications at level 8 therefore reads: conduct investigations of complex problems, including the design of experiments, the analysis and interpretation of data, and the synthesis of information to provide valid conclusions. The same outcome statement for qualifications at level 6 therefore reads: conduct investigations of well-defined problems, locate and search for relevant codes and catalogs, and to conduct standard tests and measurements. Each standard has a defined knowledge base specifying the minimum total credits, the credits at the exit level, and the baseline credits in each knowledge area. The knowledge areas in general spans mathematical sciences, natural sciences, engineering design, computing and IT, complementary studies, possibly work-integrated learning, and credits for redistribution. This slide shows the baseline for the two types of certificates at level 5. Type B is aimed at engineering support occupations where there is no need to progress to the advanced certificate. Type A has more credits associated with mathematical and engineering sciences and engineering design, and allows for seamless progression to the higher certificate. Both types have a total of 140 credits. Here we can see the baseline for the two types of qualifications at level 6. Note that the 140 higher certificate plus the 140 advanced certificate is exactly equal to the 280 credit diploma. The 280 credit diploma in engineering technology does not give direct access to the advanced diploma. The 360 credit diploma in engineering has more credits than the 280 diploma, will normally take a year longer, has a minimum number of credits specified for work integrated learning, and has slightly more credits for mathematical and natural sciences. The 360 diploma gives direct access to the advanced diploma. Here we can see an illustrative, integrated certificate and diploma structure to facilitate progression and transfer of credits. Note that the higher certificate and the advanced certificate together forms the 280 diploma, which is also equal to Part A of the 360 diploma. Students holding a 280 diploma will therefore have to complete Part B of the 360 diploma before they will be able to gain access to the advanced diploma. The advanced certificate, the 280 diploma, and the 360 diploma are all at level 6 and all meet the educational requirements for registration as a candidate technician. But since the 360 diploma in engineering takes a year longer to complete and includes a work integrated learning component of at least 30 credits, the minimum candidacy phase denoted by CP for a person holding a 360 diploma in engineering is a year shorter than for holders of a 280 credit diploma in engineering technology and for advanced certificates. These candidates have a minimum candidacy phase of 4 years before they can register as professional technicians with HEQSA. Here we can see the baseline for technologist qualifications at level 7. Both the advanced diploma and Bachelor of Engineering Technology meet the minimum educational requirements for registration as a candidate technologist. In this slide, we can see an illustrative Bachelor of Engineering Technology structure. Each full block represents 28 credits, or 1/5 of the total hours in a year. ES stands for Engineering Science, MS for Mathematical Science, NS for Natural Science, CS for Complementary Studies, CIT for Computing and IT, and so forth. To register as a professional technologist, a BEngTech graduate will have to complete a candidacy phase of at least 4 years, and an advanced diploma graduate will have to complete a candidacy phase of at least 3 years. Here we can see the baseline for the BEng or BSc Eng at level 8. In total, the BEng standard specifies a minimum of 560 credits. To register as a professional engineer, a BEng graduate needs to complete the candidacy phase of at least 3 years. Although the BEngTech Honours does not lead to registration as a candidate engineer, the exit level outcomes and allocated credits to different knowledge areas when the Bachelor of Engineering Technology and the Bachelor of Engineering Technology Honours is viewed as a package have been designed to meet or exceed the BEng standard so that the BEngTech Honours can provide access to an MEng degree and that the engineer and technologist streams can converge at the master's level. To conclude, I hope that you've enjoyed this presentation and found it useful. For more information and to access the engineering standards, please visit the HEQSA website.